Okay, hi. I just wanted to talk to you a little bit about Storacha, the decentralized hot storage network that we are attempting to build. Some of the cool features that are inside it, and how you might build cool architectures uh, around what is there to make the most use of it. So let's just try and dive in. Let me just zoom in a little bit. Um, so here we have kind of a little diagram here. This is the kind of network that we're sort of deploying and iterating on and developing right now. It's built on the back of Web3.storage. And Web3.storage is already there, kind of centralized sort of system, but it is rapidly becoming completely decentralized. But in there, there's already like an endpoint where you talk to the service. There's already a IPFS gateway, a way of accessing IPFS content over HTTP. And then kind of clients come along and they sort of send requests or invocations to us, which they actually use this novel auth system called UCANs, and they ask to store a car file, and car files are just a kind of archive of of some hash data that you've created, that the client has created. And anyway, it asks to store a car. The the service would then say, okay, yeah, you can store that. You're going to need to put it here, and that'll give you like a URL of where to put it. First of all, it needs to sort of coordinate with the Storacha network. But once it has a URL to put the car file, the content archive, it will be able to put it to that particular node. So the client puts the data to the node. It also does some cool things like publish what we like to call like content claims, which are sort of extra information about the content that has been added. So like an index for all of the content in the file, a location, so exactly where you can read that data. Um, and so we've got, just to sort of zoom in a little bit on the network here, we've got these nodes here, which are essentially kind of buckets or storage buckets that get rewarded for participating in the network for both hot storing data and retrieving. Some of these nodes can even be Filecoin nodes, and we're actually hoping that Filecoin node operators, their unsealed copy, will be able to be used to be served to the network, and that they'll be able to be rewarded for doing so. So it puts that data, it publishes some claims, and then once it's done that, it will just tell the service that it happened. It's another invocation to say that it happened, and the service can then sort of verify that that did actually indeed happen. Very cool, very cool. What happens next? Well, when people come to read that data, they typically in IPFS land use a gateway, and they'll ask for like the SID of the this is the hash of the content that got uploaded, and the gateway just basically asks this content claims system for like can you just give me all of the claims that you've got for this particular hash of data, and it'll send it back information. So in this case, it's got what we like to call a location claim, that says that you can find it on this particular node, and within that file, you can find it at this particular byte offset, and from here to here. So it will go away and read it, and then serve it straight back to the client. Cool. So that's basically how kind of storing data works or will work on the network. And what we're kind of built upon is this cool new technology called UCANs, which are user-controlled authorization networks. You can think of it as like decentralized auth, but the key is as with most kind of Web3 tech is kind of cryptography and public and private keys. But UCANs come with extra benefits, like they allow you to delegate capabilities to other people and make invocations on other people's behalf because you've been delegated these capabilities. And it's cool, kind of offline first awesomeness. And it allows you to do like some kind of interesting architectural choices with applications that are being built on top of the system. So, for instance, this is kind of like architecture you might see in like a very sort of Web 2 kind of style where the developer over here is going to be paying for the storage on behalf of its users. And it's completely transparent. So its users don't know that they're necessarily using web3.storage, but what happens here is the developer sort of registers with the web3 storage service, or Storacha service, as it will morph into soon. And then they'll sort of be in charge of the space that they can things can be uploaded to, and they'll delegate a capability to the app that they're building that says, and the delegation will basically say, okay, give this identifier did key apps. This is a public key, so the developer has a public key as well. It'll say you can this app can upload to this space, and you can give it like expiry dates, and you can revoke them and all of that. But that allows the app to upload to the space, and then the users will sort of upload all of their data to the app, and the app sort of proxies it through to the hot storage nodes. So the app, just like in our previous diagrams, will ask a service, can I store this car file? The service will reply to say, yes, you can store it here, and that's sort of how it happens. So this is very like Web2 style-y sort of way of architecting it. If you take this a bit further, so this is the kind of the more interesting thing where the developer still pays. It's still a transparent storage provider, but instead of the app having the burden of like egress costs because it's proxying all the data, what happens here is that the developer can delegate to the app as before, but the users of the app basically ask the app for a delegation, and they get delegated capability to upload to the app space, and that can be very short-lived, so they can only use it once perhaps. It is revocable, obviously, all UCAN's revocable, and it can be restrictive, so you can basically say, and you can only upload this particular thing that you've said that you wanted to upload, and it's going to be this size. So you can ensure that they're uploading just the things that you want to upload, and then the user gets to upload directly to the hot storage nodes from their browser or wherever they are, which is kind of fun. And it doesn't have to go through your app, and then your application is just like a very minimal sort of server or set of servers, I guess, however you want to do it, that just redelegates capabilities to users for temporarily doing things. So this is another kind of option. Third kind of common one that we've seen is like the developer just basically builds the app and then doesn't really have much to do with it. The users sort of, will get the app somehow. So it might be like a website, or it might be like an installed app or something. But the users basically register with Web3 storage, and they bring their own space, and they pay for all the storage, and then they upload directly to the app. So the developer and the app are not really part of the flow in terms of like the storage anymore, because the users are bringing their own. So that's kind of three kind of interesting different ways you could architect applications. I don't know exactly how that might apply to what you're doing, but maybe it gives you some ideas, which is great. And so the final thing I wanted to talk about was like the UCANs and the idea of invocation. So I did mention this a little earlier. I just wanted to talk on this a little bit. Whenever you make an invocation with a UCAN, you use your private key to sign the invocation. And the invocation is basically a set of tasks that you want the recipient to perform, basically. So you kind of sign it so it's verifiable that that particular key set signed that information, and then that is sent off to the recipient. In this case, it's just we're talking between Alice and Bob, but it could be client server, whatever. And then once the recipient has like done the tasks that it's been asked to do, it will send back a receipt, and this is also signed by like Bob and his key pair, right? And the receipt contains like the result of running the task, and also like a bunch of tasks that might need to be done asynchronously by either like Bob, or it might be Alice that needs to do a task as well. And so you get back this sort of signed receipt, and it also references the original invocation. So actually you sort of build up this kind of chain, this verifiable chain of events that happened in this way. And actually, we saw this all the way in. Let me just zoom. See if I can go back all the way to here. Oh, just here. This invocation here, when we stored a car, we got back a receipt, and there was a task inside it that for the client, which said you can put it here. And actually, what the client's doing was when it says I did it, that's just a receipt for the task that it got asked to do. And then you've got this chain of events. So you've got the original invocation that asked to store it, the invocation back that said put it here, and then the invocation that said I did it. So there's this whole sort of chain of events that you can follow with UCANs and UCAN invocations, which is great. So that's used in that HTTP put, but we also use it in like our Filecoin aggregation pipeline. So when you upload things, you can also ask for it to be stored on Filecoin for big, deep, long storage. And for that, we have to do this whole aggregation process where we take all of the data and kind of aggregate many different smaller pieces of data into one bigger chunk. And you can actually, due to we've got a whole system for how far that gets through. So you can tell when your chunk has been added to an aggregate, and you can get like an inclusion proof to prove that it has been added, and then you can follow it through to the point at which it's been added. It's been added for a deal on chain as well, and so you can follow it through in this exact same way. But this is another kind of awesome thing about UCAN invocations. So aside from delegation, we've got this whole verifiable, like the little mini blockchains, I guess, is what you can think of. But yeah, so there's some of the cool things, and that's about all I wanted to say. Thanks for listening.